Solving problems is not doing math. Hi, I'm Sarah. I've been a math and science teacher for 20 years, and I'm here to make math engaging and fun. Oh, click on the link, do the stuff, like, subscribe, follow. There's so many different ways that you can teach the relationship between integers. And again, if a student doesn't have a solid foundation with this, it's going to be really hard for them to go through algebra because there's so much that we talk about that is like where we talk about like canceling out and getting rid of these things, right? Keeping it in balance. So ultimately, you've got to understand that like if I have a positive 5 on here, I can't just take away that positive 5, right? I need to put a negative 5 there so they cancel out. But I also have to put the negative 5 over here. Okay, so those are things that you've got to really understand. So we've got the positives, and I know this is I'm trying to make all of these say 1 so we don't get too confused. The blues are the positives and the reds are the negatives. So you can honestly use any sort of manipulatives. You know, I've got some discs in my room that are like two-sided little counter tokens, right? You can use anything. You can use coins, you can use like flashcards, Post-its, whatever. But ultimately, the big thing to understand is that 1 negative, 1 positive, that's 0. 0 pairs. So I could put as many here as I want to, right? But that's 0 because you have +1, -1. 0 pairs. If I give you $1 and then I take that dollar away, you're still at 0. 0 pairs. So let's just start with 2 minus 3. Now, also when you're doing this, you would look at like, you know, what are these different numbers, right? So if I had, I know I'm kind of jumping all over the place, but so if I had this here, what number would this represent? Well, I've got 2 positives, but I've got 4 negatives. So these are going to cancel out. I'm just left with -2. So if I have +2 and I need to take away 3. So what I need to do is I don't have 3 so there's 2 different ways you can go over this, but we'll do both ways, right? But if I'm just going to take away 3, I don't have 3 to take away. But if I put in these 0 pairs, now I have 3 to take away. And I look at those 2 canceling out, and what I'm left with is 1 negative. So it's -1. So that's one way to show it. Another way that you could show it is, if you start with 2, you can just put in one of those 0 pairs because now you have 3 positives to take away. You're left with -1. You can also explain that this is the same thing, and this is sometimes a jump that they're ready to make, but sometimes they're not. And you can just show that to them, and if you see that look on their face and you go, never mind, let's try another one, right? So if you have that -3, you can say, well, it's also the same thing as just adding -3 because look, I'm still left with the same thing. I'm still left with that -1. So now if we have that 2 minus -3, okay, so I'm still starting with +2. Now I need to take away -3. So it's the same thing, right? When we're taking away, we need to start adding in those 0 pairs, right? So we're going to take away -3. So I can't just add in 3 negatives to take away, right? But what I can add in are 3 0 pairs. So if I put in 3 0 pairs like this, that's still +2. I haven't changed anything about it. That's still +2, but now I have 3 negatives to take away. So that's +5. If you do this a few times with students, they will usually make that jump to be like, oh, wait, so it's the same thing as adding. There it is. That's it. 2 minus -3. It's less negative, which means it's positive, which means you're adding. It's helping them realize that there are so many different ways to look at something. And if you put emphasis on them just memorizing the algorithm will work, but they may struggle to understand how to apply it in a new context. Meaning, they may not realize that it still applies to fractions or decimals or things like that when they start kind of, when they just memorize it, they're like, oh, well, that you just put the two lines, you take the two lines and you make them into a plus and it's add, done. But the concept isn't there. They just know how to solve that problem. They're not doing math, right? And that's a big difference.